Okay, in this video, we're gonna try to work this problem concerning the floor function. We wanna find the floor of the square root of n times n plus 1 with n in n. So this is the notation for the floor function. Okay, note that if n is 0, this floor is 0, because here n times n plus 1, which is n times 1, which is 0 times 1 is 0, and the square root of 0 is 0, and therefore the floor of this 0 is just 0, because the floor of an integer is itself. Okay, so we're gonna assume that we have n bigger than 1. Okay, so n is bigger than 1 in our case here. Okay, so one key idea that we're gonna start working with is that we need to find the floor and show that it's the smallest, because the floor of some number x is the smallest k, such that k is less than or equal to x and less than k plus 1. So the floor is this number here, which is an integer, which is less than x, and x is less than k plus 1. Okay, and in that case we say that the floor of x is just k. Okay, so this is the notation that we're going to use. Okay, one key idea that we're going to use here is that we have these two numbers, n times n plus 1. These two numbers are consecutive numbers. Okay, and we're going to use that a lot here because we are working in the set of integers, the positive integers. Okay, one quick idea that we can use is that here we have n plus 1. Okay, so if we assume that n plus 1 is bigger than n all the time, because we have n bigger than 1. Okay, and let's do it this way. N is less than n plus 1. Okay, if we multiply both sides by n, we're going to have n squared is less than n times n plus 1. Okay, now taking the square root of both sides, and the square root is an increasing function, nothing is going to change except that we're going to have the square root of n squared is less than the square root of n times n plus 1. Here the square root of n squared is just n, and therefore we have n less than the square root of n times n plus 1. Okay, we are just using algebra and the ordering of elements. Okay, so now the key idea here is that the floor function is an increasing function. Okay, so this is less than this number, so n is less than the square root of n times n plus 1. When we apply the floor function, we're gonna have the floor of n less or equal than the floor of the square root of n times n plus 1. Okay, remember that something is increasing. If a is less than b, then if we apply a function that's increasing, we're going to have f of a less than f of b. And in our case, f is the floor function. Okay, one key idea here is that since n is in n, the floor of n is just n, and therefore we have n is less than the floor of the square root of n times n plus 1. Okay, so this is good. Okay, so now this is the floor. Okay, but we need to show that this is the smallest one. Okay, so is there any smaller one here less than this? So the key now to prove that, can we find another one? Let's say alpha less than n plus 1, the floor. This alpha must be an integer. Okay, so that means if we can't find one, that means n is the smallest integer that's less or equal than this one, which is the floor of it. Okay, in that case we can conclude that the floor of the square root of n times n plus 1 is n. Okay, but can we find such an alpha? Yes or no? Okay, no, because we can see here that the square root of n times n plus 1 is less than the square root of n plus 1 times n plus 1. And this gives us the square root of n plus 1 squared, which is n plus 1. So this is less than n plus 1. So we can't find, this is good and key idea, we can't find an alpha that's included between two consecutive integers. Okay, let's say you have 3 and 4. Okay, these are integers. Can you find an integer that's included between them? No. Therefore, there is no such alpha, and this means that alpha n is the smallest integer that's less than or equal than this value here, and this means that n is the floor of this the square root of n plus 1 is n. So we can conclude that the floor of the n times n plus 1 is n, with n in n. Okay, see the steps here. Okay, I tried to explain them here. So the floor, there is no small value than n. There is no smaller value than m. Smaller value that's then, or bigger value than m, that's that can be the floor of this, because of this of this property here, of this ordering here. Okay, if you see any errors or mistakes, please let me know. Thank you very much.